Hello. In this video, we're going to learn how to use reference angles, and we're going to learn about reference angles. To begin, let's review our trigonometric functions, our trigonometric identities. We know that sine is opposite over hypotenuse, and in terms of a circle, that's going to be y over the radius. When we talk about a unit circle, that radius is 1. But if we're just talking about a circle in general, the radius is r. Cosine is adjacent over hypotenuse, which is x over the radius. And tangent is sine over cosine. And whenever you simplify these fractions, you're going to get y over x. Cosecant is the reciprocal of sine, so it's r over y. Secant is the reciprocal of cosine, so r over x. And cotangent is the reciprocal of tangent, so cosine over sine, or x over y. So in this example, we are going to find cosine and cosecant when we know that tangent is negative 5 over 12. And then they told us that sine theta is greater than 0. So that means that sine is positive. That's a very important piece of information for us to be able to find cosine and cosecant. So let's look at something from our unit circle. We know that cosine is x and sine is y. That's going to come into play here in just a little bit. But that is something also very critical to know. Cosine is x, sine is y. X and y go in alphabetical order, and so do cosine and sine. Here are our trig identities from the previous slide, because we're going to need those in a minute as well. So let's look at the information we do know. We know that tangent is negative 5 over 12, and that we're looking for cosine and cosecant. That's what we're trying to find. We also know that sine is greater than 0. So we're going to use a coordinate plane because we know that this relates to x and y, and we can plot it and get a better visual of what we're looking at. So we know that tangent is y over x. So that is going to be y over negative x. The y is 5, and the x is negative, and it's going to be a negative 12. Why did I say that the x was negative instead of making the y negative? Because we usually don't have negatives in the bottom of our fractions. Well, it's because they said that sine is greater than 0. Sine has to be positive. And we know that sine is 5. Sine is y. So the y has to be positive, so 5 has to be positive, which makes 12 negative. So I plotted this point. I went out 12 to the left and then up 5. I counted by 2s because if I wouldn't have counted by 2s, then I wouldn't have been able to fit 12 on this coordinate plane. So we're going to make this, that's negative 12, 5, and we're going to make this a triangle. Okay, we know that negative 12 is the x, so it's going to go next to the x, and that 5 is the y, so it's going to go next to the vertical side. And we are looking for our hypotenuse. Okay, so to find our hypotenuse, we have to use Pythagorean theorem. A squared plus b squared equals c squared. We know both of our legs, so we know 5 squared plus negative 12 squared equals c squared. Be sure to put that negative 12 in parentheses, because if not, it will make your entire answer wrong. And that's 25 plus 144, which is 169, and the square root of 169 is 13. So now we know that the hypotenuse of this triangle is 13. Now we can find our cosine and our cosecant. Cosine is the x value over the radius, or the adjacent over the hypotenuse. Our theta, our reference angle, will always be the angle next to the x-axis every single time. Our reference angle is always the one next to the x-axis. So the side adjacent to that is negative 12, and our hypotenuse is 13. So even if you didn't know the relationship between x and y, x, y, and r, you would still be able to determine this because you know adjacent and hypotenuse. Cosecant is the reciprocal of sine. And the reciprocal of sine, if sine is y over r, cosecant is going to be r over y, which is going to be 13 over 5, because radius is our hypotenuse, our radius, and then y is 5, so 13 over 5. Reference angles will always be next to the x-axis. That is so important. That's why I put that little note down there, so make sure you know that. Okay, now I've been talking about reference angles. Let's actually discuss what a reference angle is. It'll always be next to the x-axis, and it's always going to be less than 90 degrees. It's always going to be an acute angle every single time. So what happens if I give you an angle like 218 that's larger than 90? How can we find the reference angle? Well, let's look to see what this is going to look like on a coordinate plane. So 218 is all the way around here. So that full rotation that line just made was 218 degrees. But we want to know this angle right here, the angle in between the x-axis and this line. Now that x-axis is 180 degrees. It was half a circle. So we need to know the difference in between these two. So we can say 218 minus 180 because I wanted to find the difference, and difference means subtraction. And that equals 38 degrees. So our reference angle is 38 degrees. Let's look at another one. This time, what if I ask you to find the reference angle for something that's measured in radians? 5 pi over 9. That's a radian measure. Remember, the reference angle has to be next to the x-axis. I keep saying that because it's so important. I put it on every single slide. All right, 5 pi over 9 is equivalent to 100 degrees. There it is right there. It's so beautiful. This time, I need to know my theta right here. The theta in between that line and the x-axis, not between that line and the y-axis. Yes, that would be a very small angle, but that is not what we're looking for. So here we know that in the same spot where we had 180 on the previous example, now we have pi, because 180 and pi are equivalent. 180 is the degree measure, pi is the radian, but they're equivalent. So I need to find the difference between this x-axis, this negative x-axis, and my line. So this time I'm going to say pi minus 5 pi over 9. How am I going to subtract these whenever I don't have one of your yellow calculators? Oh no. Well, we're going to use greatest common denominator, or common denominator, not greatest, common denominator. So 9 pi over 9 minus 5 pi over 9. 9 minus 5 is 4. So it's 4 pi over 9, and that is my reference angle. So that concludes this video regarding reference angles.